All right, check out my cool shirt here. So, in this video, we're going to learn about theming and how I declare colors in CSS. I think this will be quite interesting. So let's jump into the blog post, which I will link down below. So here I am, move myself around, I'll put myself there. Cool. So like I said, this blog post will be linked down below. And just before I start, I want to say that I'm not particularly great at CSS. I mean, CSS is something I really like. CSS, I actually sort of love CSS. It's something I want to get better at and improve upon, but I'm by no means an expert. And I think hopefully today, sharing stuff will help me get better at it. But anyway, what this blog post is about defining CSS colors as well as theming as well, ways you can do that with CSS. And I think CSS makes it really easy. Now, before I jump into more detail, I just want to give a shout out to one of my lecturers in the University of Auckland, because I still have the notes, because in what I studied in university was optometry, and in optometry we learned about color theory, and that's quite important for colors in CSS. So I just want to start off with a few definitions before we continue. And the ones that are particularly important are brightness and lightness, as well as you could say saturation and chroma. So as you know, we know colors are red, green, and blue. Hue is sort of, like I call it the characteristic of that color, like blue, green, red, the differences between those. Then you got different shades of red, different shades of green, different shades of orange, etc. And you can describe them in two ways, like by their brightness, which you could say how much white you've added to this color, versus the lightness, which is what you perceive, because what we'll learn later is not all colors are the same or perceived the same. And saturation is, you can think of how much of that color is. If it's going to be washed out, it doesn't have much saturation. If it's too bright, or not really bright, but too much of that color, it's more saturated. But that doesn't account for the brightness, the difference we have in different colors, which we'll talk about in a second. And then chroma is kind of the definition of similar to saturation, but it accounts for that kind of perceived brightness of different colors. And it'll make sense later down the track. So why do we care about defining colors, or how we define colors? This is kind of a meta topic. And from my opinion, I think if you develop an application, maintenance is a really big, difficult thing that I think it's sort of an unsolved issue, or not really an unsolved issue, it's something that you have to think about, because one of the hardest things about software development is sort of wrangling complexity. As things become more complex, it gets hard to develop, more bugs sort of creep in, and it really makes your development process a lot slower. So being able to manage complexity is really important. And I think one of the markers of complexity is, for example, I'll put it in here, is hard-coded colors. It might seem like a small thing, but I think these small things do add up, and it requires a lot of discipline to not ignore these sort of small things. And I think if you have something that's themed very well, you define your colors very well, then it can help reduce that complexity in one way. So, and like a classic example would be if you've got multiple grays hard-coded in different places with different colors, or you've got the different shades of blue in different places, then it becomes sort of annoying, or your application doesn't look pristine, like if you've got different colors. And the fact is, it makes it hard to maintain and manage if you've got different colors in different locations. So you want to centralize it and basically theme things in the right way. And that'll make more sense, especially if you've got light mode, dark mode, different versions of different colors, etc. And I think another why would be, why bother theming? Like, what's the point of having a theme, I went to a talk recently and they said dark mode doesn't actually protect your eyes or make things more comfortable, but it does make perception of your application better if you have that option. I think it's always good to provide that option, because dark mode is perceived as being more comfortable for your eyes, but if you have things like light mode's easier to view things in when you're outside, out and about, and also it improves focus apparently as well. I don't have any data to back that up, but that's what I've heard. So that kind of explains why I think CSS colors, definitions, and theming is important. Let's actually move on to how I did sort of theming, or how I declared my colors. So when I declared my colors back in the day, I'd use just hex codes, which is basically almost a one-to-one mapping with RGB. From my understanding, you have RGB, the values, which go up to 255, and then that number is turned into a base 16 number, and that's where you get the hex codes from. That's basically it. You can see here, any combination of red, green, blue gives us the colors that we can see on the screen here. But one of the downsides is, let's say we've got a color, I'll try and make, you know, for example, orange, this kind of orange here. Now, if you have your base orange color and you want to create variants of that, it's like more washed out orange, or if you want an orange that's brighter or darker, that's not intuitive with RGB. You've got to put into some sort of converter to be able to change it. So it's not really easy to do. So you can define your color here, and you can have different definitions of different hex codes, but it's hard to find that mapping if you want to make very small adjustments. So that's where HSL comes in. So RGB is red, green, blue. HSL is hue, saturation, I believe luminance or lightness. And if you recall from what the definition of lightness is here, or the definition is up here, we've got hue as being, you know, the characteristic of the color. Saturation is how much of that color you get, how washed out it is, and lightness is how bright it is, or how much whiteness there is. And not exactly how much whiteness there is, but that's the idea. And you got a symbol alpha, which is basically how transparent that color is, which is not really relevant. Now, if we have a particular orange, let's see if we could try and match this orange here. So I've got that characteristic of orange, and like that particular orange, and I can, you know, dial down the saturation, make it more flat grayed out. So if you want like a disabled orange button, you can do that. Or if you want to, you know, increase the brightness, have like a variant where you got a bright orange or a darker orange, I mean, you can easily do that. So that's where HLS truly shines. But the downside is that I'm hoping that this makes sense here, this is not too misleading, and I'm not in the way. So the benefit or the disadvantage of HSL, well, the benefit of HSL is that you can manipulate saturation and lightness, but keep that same color, which is good for theming. But the downside to HSL, and it can be quite challenging to see. So how this sort of grid is laid out is on the top, so you have individual colors defined by hue, and then and we've all got the same saturation here, and on the rows we should have effectively the same lightness. But by how our eyes work is certain wavelengths of light are perceived, you know, more brightly or more intensely than other colors. So you can kind of see that if you look at, like, especially the mid-tones, which is probably the most important row. Like, obviously these rows here aren't very useful. Like the top kind of colors and the bottom colors won't be used as much. But that mid-zone is where you kind of see that greens look more brighter than blues of the same level. And that's just how our eyes work. So the retina, we have four photoreceptors, 2 categories of photoreceptors. You've got your rods, which for night vision, and you've got your 3 cones, which is for scotopic vision or daylight vision, and they help you see color with 3 different types of cones, because they get excited by, you know, red, green, blue, and the combination of those provide what we know as color. But not all colors are the same. Some your eyes are more sensitive to some colors than others. So that's why we see, for example, green looks brighter than the blues do of the same column. So that's another problem. And I think it relates to the Helmholtz-Korolf effect, where, you know, different colors have different lightnesses. That's why that's a distinction between lightness and brightness. And also, like, just to throw a spanner into the works, colors that surround a particular color can also affect how it's perceived as well. But that's for later. That's called color constancy, as well as you know, contrast as well, which is really important, which we'll dive into a bit later with light and dark mode. But you can see the problems with HSL. The evolution of that is, I can't pronounce the name correctly, but it's Bjorn Ottsen. So he developed a better color system, or a better way of defining colors, and that is through OKLCH. So LCH already existed as another way of defining colors with luminance, chroma, and hue. But OK apparently is just a better version of that because it's OK. And instead of having, it's very similar to HSL, but the main differences are you've got chroma and you've got this thing called L, which is the perceived brightness, or perceived, you know, brightness rather than just the lightness of the color. This isn't really working, this sort of color picker here, but you can kind of tell, like, if I change the lightness, the color changes. So there's something wrong with how I've set this up. But that's not important. What's more important is the definition of colors here. You can see that, I mean, this could be a bit misleading. We don't have as many we don't have much spectrum of the brightness lightness here. But I would say, and it's not perfect, that if you look across the rows, the colors appear to have that same level of brightness as opposed to up here with HSL, where you kind of see the variation around here, like it just kind of, especially this row here, you can see the big difference between the colors. But down here, it's a bit more standardized and a bit more stretched, similar across the rows, which I think is really good, because that means when you're setting up your color system with the color maps, you can give the same change in, I believe, this is colors across here, defined by hue, and over here we define this by L. You can change the colors by the same L value, and you get similar sort of changes in that brightness, which I think is really important for defining colors. So that kind of explains different ways of defining colors. The next stage I want to talk about is the way you will define, how would you do this in the application. So typically I'd use hex codes, which obviously have that mapping to RGB. But the problem is when you convert them to RGB, it kind of gives you this really ugly sort of decimal output, because you can also improve by using different units. But I'd much prefer using hex codes to define my initial colors, because when you're working with designers, I mean, you don't want to convince everyone to use OKLTH. That's a difficult task, but it's actually quite nice. A lot of color systems or design systems use hex code still. So it's kind of good to be able to stick to that. Now, CSS has a really awesome feature where you can provide a base color and then manipulate it using either RGB, HSL, or OKLCH. So my proposition is you define your colors with hex codes like we've done here. And then if you want to provide a variant, like light blue, for example, you use OKLCH. You provide you can see the syntax here, you provide your base color that you want to use. And then after that, I think you need a comma here, I think the syntax might be wrong. But you provide your L, for example, so you can just provide L, and then I've done a calculation on here to adjust it. And then you can provide the other the other factors or the other parameters that relate to this color. Even though it's in a different color format, hex code, it'll still pick these values out. So here, for example, we've increased the brightness, the L value of the blue while keeping the chroma and H the same. And that makes it a bit lighter. And the benefit of this is you get the benefit of OKLTH, but you still have the benefit of being able to define colors in a simple way using hex codes. Now, I usually put this in a .css file, call it colors, and you can import it as CSS variables throughout your entire application. Now, the next thing is theming with light and dark mode. So we sort of discussed how we can use CSS, we sort of discussed how we can define our colors in our .css file. But how do we account for light and dark? Because if you use a particular blue, it won't look good on a dark background. Like a dark blue is hard to see on a dark background. You want to change that to a lighter blue so you can see it on a dark background, and vice versa. That light blue won't work on a light background. It needs to be darkened down. So we can use light and dark to define our colors with two sort of different variants. Now, this is how you'd set it up. So in a root file, you do color scheme, light and dark. You provide I call it base blue, and then you can do dark blue, which is the exact copy of it. I mean, what you could do is you could have your sort of middle blue and then have a darker version and a lighter version, but I've not done that. I just use the same base blue as my dark blue, you could say. Then you wrap it inside light dark. So we're saving blue as a CSS variable. We use light dark to have your dark. This is going to be our dark blue, which is going to show on a light background, and the light blue, which is going to show on our darker background. And the syntax is not working here. But here we can have what we call data attributes. So these are sort of custom attributes where you can change it with JavaScript, or if you can write fancy CSS to be able to set the particular color scheme, light or dark. And if you don't set the theme, it just defaults to the system settings, which is what I think by convention you should try and default to system settings, but also provide the option to change, because you might have dark mode on your operating system, and you might want to have light mode for a particular website you're browsing on. So you always want to give your user an option. Now, here's an example here where we just have the system settings, and I'm currently on dark mode. And how this is set up is we've got our light blue showing up on a black background. If I switch to dark, it doesn't change because it's the same color scheme. If we switch to light, you can see that now it goes to the white background, which is typically what you'll see with light mode, where the black border and see how the color of the text has changed to the dark blue variant, which I think is pretty cool. So you can go back dark, go light, you can see it switching there. Cool, and if you're wondering, like with the example here, if you come this far into the video, how if I reduce or change the chroma or the lightness here, can you see how like the words are changing here? There's another really cool CSS called contrast color, which I believe just came out April 2026, so a month ago. Where so just remember to just check can I use for how widespread it is. But the benefit here is you can provide your background color and it'll pick if it's going to show white or black. For that people that might be like a deal breaker, because like for my personal website here, this is actually not white, it's like an off-white. And if I change the theme to light mode, this is actually not black, it's like an off black, so that could be a deal breaker for some people, but I mean for some situations it works pretty well. So that's another cool little CSS bonus feature as well. Cool. So this sort of blog post didn't spring out of thin air. Obviously I've made some shout outs to my lecturer where I got the notes for the color theory. But also really cool talks here that I'm linked to, the Dylan Beatty's Rethinking CSS, which basically just goes through, this is like almost a hash, just a small part of what he's talking about in his talk. Kevin Powell's really awesome, I love his videos on CSS, and he sort of has a video explaining light and dark a bit better than I would. Also, really cool documentation here. This is an awesome blog post by Evil Martians, where they talk about how they've switched from, I'm in the way, but they've switched from using the other forms of defining colors, RGB and HCL, into OKLCH. So that's the end there. I know I rambled on for a little bit, but I really appreciate you watching and getting this far into the video. I hope you found this useful. If you have any sort of advice or tips for me, please let me know down below. And my goal is once a week just to share something I find interesting via blog post, try and post it on LinkedIn or Blue Sky, or put it on YouTube or share it somewhere. It's just learn one thing. It doesn't have to be amazing. Something I find interesting and just share it online. Cool. Other than that, take care and happy coding.